Now we will prove the principle of mathematical induction by using the domino effect. What is meant by domino? Domino means rectangular tile, a set of rectangular tiles. So we arrange some dominoes in a long row, that is just like that. I am going to make it just like that. Dominoes are arranged in a vertical position. So as if one domino falls, then what will happen? If one domino falls, it will hit the another one, then another domino will fall, then another domino will fall. That will be continued. Then after falling off one domino, k dominoes fall. That implies next to k domino also falls. As we see, if we have k dominoes, just like this is the k dominoes, the next one is this one. If k dominoes fall, then next will again fall. So, according to principle of mathematical induction, if result is true for n is equal to 1, that is one domino falls. Then, if further we assume result is true for k, that is we assume k dominoes falls after the falling of one domino, then next k plus 1 domino will also fall. Thus, we can say that as it is true for one domino, that is k is equal to 1, then it is true for k dominoes, which implies it is also true for k plus 1 dominoes. Thus, we can say that given sequence of dominoes is true for n belongs to natural number. That is our principle of mathematical induction. Now the next one is we are going to state the principle of mathematical induction in the form of logical symbol. So, principle of mathematical induction in logical statement. That is, for all statement P of 1 and for all k belong to n, P of k implies result is true for P of k plus 1 for all n belongs to n, for all P of n result is false. So in logical statement we will see again for all P, that is our statement, result is true for P of 1 and P of k for k belong to n, then result of these two, that is true, implies that P of k plus 1 is true. Then we say that result is true for all n. So Pn statement is true for all n belong to n. That is principle of mathematical induction in logical statement. So we prove this result, logical statement. But before proving this result, we will define and understand what is a well-ordering, that is well-ordering principle, because it will be used when we will prove the result of principle of mathematical induction. So what is meant by well-ordering principle? It says that every non-empty subset of natural number n has a least element. Suppose we have a set that is A, it is started from 2, 3, 4 up to infinity. So by well-ordering principle, least element of A is 2. So well-ordering principle states that every non-empty subset of n has a least element. So on the basis of this well-ordering principle, we will prove principle of mathematical induction in logical form. So we will prove logical statement of principle of mathematical induction by using well-ordering principle. So proof of this is as, first of all, let S be a set of natural number for which Pn is false. That is, for all n belong to S, P of n is false. And we suppose that 1 does not belong to S. As 1 does not belong to S, that means P of 1 is Q. Because as n belong to S, that means the element belong to S, then result of P under that element is false. But as 1 does not belong to S, so P1 is true. Now, if S is non-empty, then by well-ordering principle, it has a least element, that is suppose t, and t is not equal to 1 because t is the element of S and 1 does not belong to S. So t is not equal to 1. Let t is equal to n plus 1. Since t is the least element of us, S, therefore P of t is false. As t is equal to n plus 1, this is the least element. That means S is started with element n plus 1 and it contains or it consists elements above n plus 1, that is n plus 2, n plus 3 and so on. That means n does not belong to S because n plus 1 is the least. As n does not belong to S, that means Pn is true. And as we know that by principle of mathematical induction, Pn is true, then Pn implies Pn plus 1 is also true. Now, since Pn plus 1 is true and Pn plus 1 is equal to P of t, that implies P of n implies P of t. That means P of t is true. But this is a contradiction. So there is a contradict result that P of t is true. So our supposition is wrong. S is a empty set. Hence S is equal to 5. So that is true for Pn. For all n, S is always 5. So principle of mathematical induction is proved here.